Hello everyone, welcome to Engineering Archives. Today we are going to look at our first practice problem for this chapter. So the problem says, the vertical force F acts downwards at A on the two-membered frame. Determine the magnitude of the two components of F directed along the axes of AB and AC. Since the axes that they have given us for this problem are once again not perpendicular, we will obviously use the vector triangle. So let's get started with the vector triangle. Here I have drawn the axes and how they would look like, and I have extended the AB and AC axes just a little bit further so that it's easier to imagine and make the vector triangle. So we are going to start with the most easiest vector to draw for the vector triangle, which is obviously the force F vector since it's directed directly downwards. So the force F vector is going to look like this. We know that the two components of the force F vector have to be in the direction of the AB line and the AC line. So what if the component along the AB axis is like this? Let's extend that a little bit. And what if the vector along the AC line is like this? So here we have a complete vector triangle. Now let's put in the angles. We can easily find this angle from the diagram that they have given to us, since this angle is the angle between the force F vector and the component of force F along the AB axis. And from the diagram we can see that that angle should be this angle right here. But we can see that this angle is similar to this angle right here. So this angle would be 45 degrees. Let's move on to this angle. This angle is the angle between the two axes, the AB and the AC line. So extending those lines, as you can see in this diagram that I have made, this angle should be this angle right here. And to find this angle, we should find this angle first so that we can subtract 45 degrees and this angle from 180 degrees. So we should do this angle first and we should come to this angle at the end. We can see that this angle is this angle right here. Since this is the angle between the force F, or the vertically downwards line, and the AC axis. So this angle should be the difference between 90 and 30 degrees, or 60 degrees. And lastly, we can easily find this angle by subtracting 45 and 60 from 180 degrees. And that would give us 75 degrees. Now that we have our angles and we have the length of one side of the vector triangle, which is the magnitude of force F is 350 pounds as specified in the question, all we need to do is apply the sine rule to find the magnitude of the components along the AB and AC axes. So according to the sine rule, component along the AC axis over sine of 45 degrees should be equal to 350 pound force divided by sine of 75 degrees. The value that we get for component along the AC axis is equal to 256.2 pounds. Similarly, for the other component, we get component along the AB axis divided by sine of 60 degrees should be equal to 350 over sine of 75 degrees. And the value that we get for this component is 313.8 pounds. So this is the simple and easy procedure for this question. Thank you very much. See you in the next